Dear students, welcome to Atoms to Infinity. Today we are going to do IGCSE's Physics Topical Past Paper. This is P4, which is theory paper, and it's the extended version. We are going to start with the chapter number 1, which is Physical Quantities and Measurement. So here I have the worksheet. It's the complete chapter 1 here, which is from the measurements. The questions are like misarranged, but it's alright because we're going to do them all. So what difference does it make? Let's go to the question number 2, which should have been question number 1, and it's part A. We have to define density here. Alright, now we know the definition of the density. Density is defined as mass per unit volume. Right, we can also write its formula. The formula is basically density equals to mass over volume. Now this is the complete answer. Let's go to part B here. Part B, it says the density of aluminum is 2.70 grams per centimeter cube. The thickness of the rectangular sheet of aluminum varies. Okay, so there's a sheet of aluminum which thickness is varying, but it's much less than 1 millimeters. But you know, it says much less than, so we're not really sure what is the accurate measurement of the thickness of this aluminum foil. However, when a student tries to measure the dimensions of all of that sheet, so mass came out to be 60 grams, 60.7 grams, length and width are given as well. You can see their readings. So in part A, we have to calculate the volume of the steel, of the sheet. Right, well, since you know volume is basically defined as length multiplied by width multiplied by thickness, but the problem is we're not really sure with the thickness. It says much less than, so not sure how much less than 1 millimeters. So we're not going to use this formula for volume. We can use this formula, which is density equals to mass over volume. So let's make the volume as a subject of the formula. That will go like this. Mass will be equals to, volume will be equals to mass over density. Now we are given with both of these values. Let's plug in the values. Mass is basically 60.7 grams, 60.7 divided by density is 2.70. Now this is 2.70. Let's find out the volume. You can calculate it with the help of your calculator, whereas I'm going to just use my own. It is 60.7 divided by 2.70. Now it is 22.48. 22.48. Since they have taken the reading of the density in centimeter cube, so the units for this volume will be centimeter cube as well. Alright. Now after that we need to find the average thickness. Now, well, it can be calculated if we use this formula, thickness, if I denote it by 3. That is actually, let me tell you how this formula is first derived. We do know that volume is given by length multiplied by width multiplied by thickness or height. Now if we multiply length with width, we basically get area. So it is basically area times the thickness. So therefore, thickness would be equals to volume over area. Now we have find the volume in the above part. Let's calculate these. It's 22.48. And now we would have to find the area. In order to find the area, we are given with the length and width. It's 50 and 30. So 50 and 30, that would be roughly 1500 centimeter. So let me just calculate 50 multiplied by 30, that would give us the area, which is 1500. 0.051. Okay, so it is 1500. Let's see what value does it give us. That would be the average thickness. Means that is the thickness which is mostly we would be getting if we try to repeat this experiment. 22.48 divided by 1500, it is 0.014. 0.014 meters. So you see, the thickness is very, very less. It is basically much less than 1 millimeter. It is 0.1, so sorry, 0.01. Anyhow, let's go to part C. Another student provided with a mean of cutting the sheet, decides to find its average thickness using a single measurement instrument. Assume the surfaces of the steel are perfectly smooth. Okay, now since the sheet is so small, you can see this sheet is very small. It's basically in the millimeter range. If you try to convert it into prefixes, that would basically mean that you are finding 14 sheet. That's very less. It's very less measurement. So in order to find it accurately, we can use micrometer screw gauge, or we can also use like vernier caliper here. These instruments will give us the best value, but I would recommend micrometer screw gauge would be the best one. Right, describe the procedure she would follow to obtain an accurate value of the average thickness of the sheet. Details of how to read the instruments are not required. Alright, we need to just describe this in the paper, that how we are actually going to use the screw gauge. Alright, so let's write it down here. We will check the zero error first, zero error of the micrometer first, and then we would fix the sheet into the, if we don't use the micrometer, then we can use vernier caliper. I'm just gonna write VC here. After finding out that there is no error, then we would fit the sheet into the jaws of vernier caliper. Okay. Afterwards, we will calculate the reading from main scale and vernier scale. Okay. We would multiply the vernier scale reading with the least count, and we will add this result in the main scale reading. Okay, there we go. That is a complete answer, complete description. This question is done. Let's go to the next question. Alright, so the period of vertical oscillations of a mass hanging from a spring is known to be constant. Alright, yeah, the period comes out to be constant. The period of a time period of a pendulum. Let's say if we have a pendulum like this, that's a support, there's an inextensible string. That is basically a simple pendulum. You can create it in your home. So right now it is at a resting position, which is O. O can be any arbitrary position. Now if we take that pendulum all the way here to a new position called A, and we leave it, it will start traveling. It would start traveling from A and all the way to O, but it will not stop here. It will go all the way up to B. Now the period is basically defined when it starts from A and comes back all the way to A, not at B. That would be half a cycle. So a cycle mean, if I have a cycle, another cycle wheel, why do we call it cycle? Because if you're starting at this point, you will always finish at this point. So let's call this point A. So yeah, you will be like traveling in this direction, then you will come back all the way here. Right, well anyways, a student timed single oscillation with a stopwatch in 10 separate measurements. The stopwatch readings are this. Well, these are the time measurement, 1.8 second. First, it took 1.8 seconds to arrive at A, then 1.9, then 1.7, 1.9. All of these readings have been taken. These are total 10 readings. So what is the best value obtainable from these readings for the time of one oscillation? That means we can basically have that reading which is getting repeated multiple times. Okay, for example, I can see here that 1.8 is getting repeated multiple times. 1, 2, 3, 4, 5. So 1.8 is repeated 5 times, whereas 1.9, 1, 2, 3 3 times. 1.7 is basically 2 times. That gives us the complete 10 readings. But the better way to measure a single value, that would be okay if you find the average. Now in average, you would add all the readings and divide it total number of readings. For example, if since I have a calculator here, so I'm gonna write all of these values here. 1.8, which is repeated 5 times, so I'm just gonna multiply it with 5, which is 9. Okay, so 1.9, which is repeated 1, 2, 3 times. Yeah. Okay, so it's going to be 5.7. So 9 plus 5.7, 9 plus 5.7, which is 14.7. Okay. Now what about 1.7? It is repeated twice. 1.7 multiplied by 2, 3.4. So 15.7 plus 3.4. So it is giving me 19.1. Let me just divide it by 10. 19.4 divided by 10. It is basically giving me 1.9. So 1.94 is basically the reading that we should use. It's appropriate. Well, the best value, of course, I mean, if you are going for the other method, that would give you 1.8. If you're saying that you want to calculate the most repeated number, that is 1.8. But if you're finding by the way of average, the average is giving you 1.9. Let's calculate the average again, because I can get it wrong as well. So 1.8 plus 1.9. You should add all of these readings to check the answers with me. 1.7, then we have 1.9, then 1.8, then 1.8, then 1.9, and then 1.7, and 2 times 1.8. Right, it's 18.1. So 18.1 divided by 10, which is 1.8. So yeah, the average, even the average that I have calculated is giving me 1.8. So that is the best value, 1.8 seconds. Now we would have to explain that how did we arrive on this measurement. So let's write it down. The method of arriving at this result is the method of taking the average. Okay. All right, let's explain. We add all these time measurements and divide it by the total number of readings. Okay, since there were 10 readings, so the total number of readings. All right. And you can also write this down. It will just give you more impact, like if you would write like this: 1.8 plus 1.9 plus 1.7. So you can just do that on your own. Okay, I'm not going to write it here. All right, describe how using the same stopwatch the student can find the time period of oscillation more accurately. Now, more accurately, there is only one method to increase the accuracy of the oscillations, and that is if we consider the significant figures. Now, significant figures can be used to just have the more precise and accurate value. You can also say that using the same stopwatch, you can also say that by controlling the external conditions, for example, air, temperature, etc. So let's write it down. First, a student can manage the external conditions more carefully, such as wind and temperature. It basically doesn't have to do with this, but the movement can be changed with the help of a wind or with the help of a temperature. So yeah, it would be more okay. All right. Second method to increase okay, whatever are the spellings, just forget them. No, hang on. Increase the accuracy is to find the error in the stopwatch and fix the error. Okay, now that's the second thing. Third, she can use significant figures to increase the accuracy of the result. Alright, that is the complete answer. You can extend it, you can add more and more things, you can always search different books to find out the answer. Alright, now question number 4. A pendulum swings with a time period of approximately 1 second. Describe how to use stopwatch to determine the time period of the pendulum. Alright, okay, it's very easy. Let me show you that first. So here was our pendulum, it was here, but we were not liking it to be here, so we took it all the way to A. Now when it is A, and when we are about to drop it, we should start the stopwatch, and it will go all the way to its new position B. And the moment it comes back from B to O and O to A. The moment it arrives on A, we would just stop the stopwatch, and that would be the measurement taken. That would be the time period. All right, let's write it down. When we have taken the pendulum, oops, that is going all the way up to there, so I would just start this from this point. Okay, a student may start the watch when she is about to, when stopwatch in the same moment when she releases the bob, metallic bob, and she must stop the watch the moment when the bob returns to A, okay, which is like extreme position. Okay, that would be the best method to do that. Okay, returns, yeah, the spellings are incorrect for returns. All right, there we go. Okay, now this is the answer for that. Let's go to part B. Complete table 2.1 by writing in each space right hand column. Okay, now here we have some quantities, and we should tell that which device should be used in order to measure these quantities. Volume of water in a glass. Now let's see, measuring cylinder. We can use the volume, we can basically calculate the volume by measuring cylinder. There we go. Now the second quantity, width of a small swimming pool. Now the small swimming pool is basically very small, so we can basically use meter rule in order to calculate it, because there is no other thing. I mean, of course we can't calculate thermocouple or micrometer screw gauge, so of course we would be using meter rule. Alright, let's write it down. Meter rule. Thickness of a piece of aluminum foil. Now aluminum foil and its thickness can be calculated with the help of a micrometer screw gauge. Micrometer screw gauge. Okay, G-A-U-G, screw gauge. Right, what do we have next? We have answers. No, we don't require them yet. Alright, a student has a large number of coins of different diameters, all made up of same metal. She wishes to find the density of the metal by method involving placing the coins in water. State the formula needed to calculate the density. Well, yeah, of course the density can be calculated with the help of this. I mean, here's a formula. Density, that would be equals to mass divided by volume. Now if you remember, volume can be calculated with the help of the measuring cylinder, but in order to calculate the mass, but the problem is she wants to measure the density, with the help of like placing them in all of these coins in water. So okay, then whatever it is, let's see how we can calculate. But it would be better if we calculate the mass by some sort of a physical balance and then we place them all in volume. So of course we're going to do this, because if I tell you the Archimedes principle is not really for chapter number 1. It is usually for chapter number 3 or 4, in which you know in which you don't really know the mass of an object, but you still calculate it with the help of a measuring cylinder. So I don't know if this is going to be used in this question. However, we can just write our conventional answer like this. Let's start writing it. The mass of all of these coins should be calculated with the help of a balance. Now this balance can be physical or it can be digital. Okay, so in physical balance we have weight balance, you know, the mechanical one, but in digital one they are more precise, more accurate. So that is a measurement for mass. After that, there should be a cylinder with a bit water in it, so that it gives the initial reading of volume. Then all the coins should be in water, and water level would rise, and there would be a new value of volume. Now make sure when you're writing in the Cambridge examination, don't go really out from this line. Okay, now after that, volume can be calculated in terms of change in volume. That would be Vf minus Vi. So that's how the density would be found. Density would be equals to mass over delta V, where if you expand this formula, then density would be equals to mass divided by final volume minus initial volume. And remember, mass is calculated in by the help of a balance, volume is calculated with the help of a measuring cylinder, and units would be kilogram per centimeter cube. Right, now let's go to the question number, now the same part. State one precaution taken when carrying out the measurement in B. Ensure that result is as accurate as possible. Alright, so you know, when we are taking the measurement from a volumetric cylinder, and let's say we have a reading like this, here is a reading, and we want to know this reading, we shouldn't be like observing this reading from this point or from like this point. So basically we should align our eyes at this point. Okay, so that is a method. That means what I'm really trying to say is that our eyes should make a parallax angle with the reading of the volume. Otherwise the reading would be a bit compromised, you know. So that is the one precaution. I hope you can write it now since I've explained it. Alright, now let's see again. Right, I believe this worksheet is done now. So you can basically reach me out if you don't understand a question. If you still have any confusion in understanding any of this question, you can comment your thoughts basically, and you can also reach me out for like better explanations. Any other question, any in general questions about anything, I would just explain it. And I hope the environment around me would be a bit quieter and there would be no sound, and still there are many things to be done, but hopefully with the passage of time everything would be alright. Now with that being said, I would just end the video here, and I'll meet you with another worksheet either on P2 or on P4, but the main thing is we would be only covering the extended syllabus. Now take care, goodbye.